Okay, so for the last part, or so for the last video in this series, I'm going to show how we can start to automate the design of steel elements as well using SpaceGass. So for starters, I'll clean this script up a little bit. I'm just going to drag these down here. I'm going to drag my modal stuff down here as well. Get that out of the road. And what I'm going to do is we're going to come back to this, the steel design component, which we talked about briefly before. It's under the solver component again. And what this component will do is allow you to trigger the SpaceGass steel design feature. This component also does basically encapsulates all the functionality of the SpaceGass solver component. So you'll see analysis result queries as well as design result queries. So I can effectively remove this solver component from here, and all my analysis type queries I could drag in into here as well. I'm just going to remove the modal stuff, and I can also, I can still set my the analysis type options that I want as well. So, and I can also set steel design options as well. So there's another component obviously that has that allows you to set some generic steel design options which are available in SpaceGass. So I can drag those into there as well. One of these, obviously, I need to provide a slenderness check limit. I'm just going to provide a 0 for there, and that should be an optional parameter. Okay, so now what we need to do is we need to set up some design result queries. Now, in order to do that, I can go to the solver component again, and I can query a beam utilization summary. So basically the beam utilization summary just takes a bunch of curve elements, but these are curve group elements. So what we need to do first, similar to SpaceGass, is set up a design group, and we can do this. In Grasshopper. So I'm just going to give myself a little bit of space there. And the two main elements I'm wanting to do is I'm just going to preview off all the modal results. The two main elements that I'm interested in are these strut elements and also the rafter elements. So what I might do is I'll start off with the strut elements because these are a little bit simpler. If I go under the Geometry Gym SpaceGass element tab, I've got to create a member group component. So I can click on this, and what this allows me to do is define a member group within SpaceGass. So if I just find my strut elements, what I want to do is I basically want to create a member group for each of these elements. They're obviously they're quite simple. So in the output here, I've got 2 branches with 9 items in each. But what I'm going to do is bring in those beams, and I'm going to get an error here, basically because these beams, it's going to take that list and try and join those beams into one element. So what I have to do here is graft this, and then I'll get my design groups that come out. Now, so what I can do here is I can actually flatten this if I want, which denotes that I've got 18 design groups. So by default, it's just going to set a fixed or an F at each end for the design, and I'm just going to quickly show you this. So what we might do is just before we go any further, I'm just going to bake this model to SpaceGass to make sure that everything, or these design members are getting set up properly. So just open SpaceGass and same procedure. So I'll just go to wireframe mode, and if I select this show steel member design groups, you can now see that these steel member design groups have been set up. And if I click on the show member flange restraints, you'll now see that, yeah, I've got an FF for all of these. So this is looking good. Okay, so it gets slightly more tricky with these rafter members, and now we're gonna delve into a little bit more complex application of the design, setting up the design member groups. So we're going to set up the design member groups for the rafters now. So if I go to where my rafters are set up, down here. What I want to do with these rafters is I basically want to set them up into three, so each rafter will have, I guess, 3 design groups. So one for the back span here, one for the internal span, and also one for the cantilever. So in order to do that, I've already got my, I've got my, I guess, tree structure defined how I want it. So I've got 13 elements in each tree, so I'm just going to simplify that for now. And then I'm going to go and get another steel design. Well, I'll just copy and paste this one here. It's worth noting here, you can specify specific names for the groups if you want, or you can just let the program calculate it for you. So what I basically want to do here is split these elements at the points in which the struts are coming in. So the way I'm going to do that is, you may recall before we selected the index, we were able to find the index at which closest matched our front and back cantilever positions. So I'm just going to get those 2 indexes and bring them over to where our steel design is. And I'm going to just split the list at these 2 positions. Now, firstly, what I need to do is, I don't care about these little end pieces at the moment. They're kind of there just for, I guess, just for show at the moment. So I'm going to cull the last 2 elements in this list just by using the 0 and -1. And then I'm going to firstly split the list at index 2. So if I can look there and I know I've got 2 elements and I've got 9 in the other one, and then I'm going to simply split that list again at index 8. So I've got 8 elements, and then sorry, what I will need to do, so I've got 2 and 9. I need to split that list at, I just need to, sorry, I'll need to subtract that 2 from that, so I'll need to split it at index 6. So I've got 6 elements in there and 3 elements in there. So now then I can, and if I set these up separately, I'm going to say my list A can go into here. My second list can go into here, and then my third list can go into there. Now I could do all these in one list, but it's going to be a little bit easier to do them as 3 separate ones. So you can see here that I've what have I got here? What I need to do is ungraph these, because basically I want it to be able to put in those 2 elements, because effectively I want to join those and make one design group from them. So if I look at my, I'll just unflatten that. So look at that now. For the 8 input branches, I've got one design group, and that specifies those 2 members. So I'll do the same here. I don't want to graph that one, and I don't want to graph that one. And then each of these should have an output of one design group. Yes. And yes. And I might just quickly export this to SpaceGass to make sure that everything's working okay. Wireframe again. I'll show the design groups, and then now you can see I've got 3 separate design groups set up there. If I turn the flange restraints on, you'll see that I've got a fixed restraints. Okay, so now what we want to do is, with the rafter elements, we know that we've got our purlins coming in and providing a lateral restraint to that top chord member, and so what we want to do is we want to be able to set those restraints in SpaceGass, because we don't want to have to manually do that. So we have some inputs here, steel design parameters. So if I go back to the SpaceGass, under the element tab, under the attributes tab, actually there's a couple of different components here which we can use. So I'm just going to drag a steel design member parameters component out. And what this allows us to basically do is set some of the options for our design. So basically, whether we want to calculate buckling properties from a buckling analysis, whether braced inputs and all that other stuff that you'd typically set using the SpaceGass form. You can also set your start and end parameters in here. So by default, they're set as F, which is a full restraint, I believe. But you can start to set these. So, and if I just drag in the design member attributes, these are how you can set design groups up to be designed. So whether you want to use the high strength grade, how you want to design the member, and whatever. So basically here we'll be doing mainly checking, but you can set these up. So I'm just going to get rid of that component there, but it allows you to do it. So effectively what I want to do is assign those lateral restraints at the top chord for the members where the purlins are coming in. So what I want to do is go again to the attributes, and I can select a steel member restraint components within the where the node restraint is set. And basically what I can do then is put in my restraint type. So I'm basically wanting to place a lateral restraint there, and then restraint position. So what I'm wanting to do is generate a list, and I can either put these positions in as actual lengths or ratio lengths. So because I know, I guess that these are going to be at equal distance lengths, I might put these in as ratios. In order to calculate those ratios, I'm going to use these numbers that we've generated down here. So I'm going to get a division component, and because it's a ratio, I'm just going to divide it by 1. So I'll and I'm going to divide it by the number of elements that are in each of these things. So I'm going to just get a list length component. So for the first set, I'm going to have my length of my lists is a panel component there is 2. So I know that I'm going to have a ratio of 0.5. And the other thing what I need to do is, because of the way that SpaceGass works, I need to duplicate that data by the amount of restraints that I'm going to want. And the amount of restraints that I'm going to want is the length of this list minus 1. So again, I'll do a negative component, or what I can do is actually just place that in there, and I can do an expression on the component. So I'll just do x minus 1 because that's similar for all. And this is going to give me, should give me 1 at 0.5. Sorry, I've mixed up my thing. So I've got 1 at 0.5. So I can drag that into my restraint position, And now I've got, and I'll just simplify that, and now I've got my the restraints that I'm wanting, and I can put these in at the top position. Okay, so now we just need to duplicate that for, sorry, that went into the wrong one. These need to go into here because we don't want to. Okay, so I'm just going to clean this up a little bit. Okay, sorry, I got halfway through that and realised that a straight multiplication wasn't correct, as it would give me a continued duplicate list of the same ratio value, whereas in SpaceGass you need to do an accumulative ratio value. So I've added the series component, which basically generates a series of integers at the length of the list. The last thing I needed to do here was just make sure that the value was a negative value to signify a ratio. So I've just added the negative components to all of these. So what I'm going to do now is just quickly make sure, go back to SpaceGass and double check to see if these ratios have come in okay. I'll just go to wireframe again, steel design, and so you can see here that my lateral, looks like my lateral restraints are coming in good. And so this is quite good for obviously generating geometry really well. If this is set up quite good, then you can start to perform multiple design iterations. So for example, say I want to change my purlin spacing now from 1400 to say 1250, and I already had moved my front cantilever a little bit, but say I want to move that back, say slightly. I can start to re-export this to SpaceGass, and these values will be automatically updated. I'll just import that again. Okay, so we've got our updated geometry. Just go to wireframe quickly. Our updated member, and I'll just turn that off. And now, yeah, so we've got our cantilevering members with the correct lateral restraints automatically updated. So what I'm going to do quickly is just to try and test if I can get a design working here. I can click this button here to get, okay, so I've got a design error for all of these elements. Now, if I just click on the element and look at the results, it's saying that I've got a non-library section with insufficient design info. Now, with these, with the steel members, I'll see if I can find it here. I might not be able to. Basically, with a section in SpaceGass, a library section, if I click on, say, a purlin element, a library section will come with a bunch of design strengths in the section. Now, our out-of-the-box geometry dream catalog doesn't have these material properties defined, which means that SpaceGass doesn't know how to design these members. Now, we can get around this in two ways. So, in one way is to go back to where we define these members and provide section property parameters. Now, if I go up to SpaceGass attributes again, I can look at the section property parameters and I can actually specify these yield strength values. The other option is to actually select a member's size or a profile from the SpaceGass database. And that's what I'm going to do in this instance, just because I'm used to using those SpaceGass members, and I know that no other data is going to be often if I go that way. So if I go to the SpaceGass attributes panel, there's a SpaceGass profile standard component, and this works similar to the material component, and allows you to search for a SpaceGass section, library section. So I just need to input which library I want to search, which in this case is the AUST 300, and I can just put in the name that I want to search as well. So in this case, I just needed to add a space in here, and then it's going to spit out a SpaceGass standard profile. So I'm just going to copy that, and I'll also create one for my 6.4 member. And then I'm just going to drag these profiles into this entwine component. So I'm just replacing the geometry and catalog with a standard SpaceGass section in this instance. And I'm going to do the same thing for my rafters. And you can do the same. You can basically check what the name of the standard catalog is in SpaceGass to make sure that you're getting that right. And I'll just drag that in there. Okay, so what I'm going to do is quickly go back and rebake that and see whether we can run that design result. Let's go back to wireframe. I'll do my analysis again. I'll run my design. And I get the warning that everything's passed. And I can start to see that some of these internal elements appear to be, I mean, everything's passed, but some of these are working a little bit harder than, I guess, some of the cantilevering elements. Now, the the way that these are set up, these cantilevers probably shouldn't have a fully fixed restraint here, but yeah, as designers, you can set this up however you like. And maybe I'll go just make sure. So if I right click on this, my steel member design results, yeah, my critical cases and whatever. So the last part of this is automating this process. So being able to get, I guess, real-time feedback on the design of these members using a similar type of process we did for the analysis results. So what I'm going to do, I'm just going to show you how to do this for the rafter members, and you guys can do it for the other members if you like. So first thing I'm going to do is I'm going to merge all of these, I'm going to merge these branches together. So basically, excuse me, so I'll have the first section and the second section and the third section, which we've created in these three design groups. I'm going to merge these into one. So again, we've gone back, we've got 8 rafters, and now we've got 3 design groups for each rafter. Now, the other thing I want to do here is basically get a curve that represents this design group. We don't have, we haven't implemented, I guess, a visualization for these design groups. So in order to visualize that, I'm going to basically get a curve component. And for my list A, I'm going to drag that in there. So I've got that curve. My list B, I've got, from this list, I've got this curve. And for this list, I've got this curve. And I can bring this over here, and I can also merge these. So now I've got, I guess, a representation curve. So what I need to do is I also need to join these curves, because at the moment I've got these as single elements, and this is effectively what the member group component is doing. So now I've got one curve, and one curve, and I'm just going to merge these. And you have to be careful with, you really have to be careful with tree structures when you're using the merge component. So this is great. So I've got my member groups and my curves, which are in relation to my member groups. So I'll just do that. So I'll get my curve. Okay, so now what I want to do is set up automated design querying. So I've got my member groups here, and I'm just going to put them into the curve elements in which I'm wanting to query. So my beam utilization summary, and then I can put those design result queries into the design result queries component. And the last thing I need to do is I need to tell the component which code I want to design the steel for. So under the SpaceGass solver panel, there's at the moment we've only got the steel design for the Australian standard, but we can I guess add different codes as required. So with this, you get some options to do with the Australian design code, which you can start to set, and then I'm just going to drag that in there. So now this component is ready to go to design to AS 4100. So I can run those results. So yeah, just again, you need to make sure that you're that you've quit out of SpaceGass or anything, any previous jobs you have open before you run that solver. Okay, so the results have come back, and you can see here I've got a steel design, member design group utilization summary, and this is similar to before. And you can also see that I've got a whole bunch of my analysis results as well within this component. So this can do both analysis and design results. And then yeah, again under the solver component, I can do a set utilization summary decompose. I can pour those design results into here, and I can start to understand how it's designed. So the total length of the segment, or the total length of the member, the segment length, I guess my ratio, so everything is above 1. And I can start to, I guess, view this on within Grasshopper as well. So if I bring my curve elements over here, and I just need to flatten this as well, I can do a similar thing what I did before. I'll just get the middle of that curve, and I'll, depending on what ratio I want to use, let's turn the preview on for this. So yeah, so then you can see your utilizations of these members. So I've got 3.4 here, 1.5 here, which is what we were sort of seeing from SpaceGass as well. So what this allows me to do is start to get a quite quick feedback on design of elements. So maybe I want to reduce the span of this, the middle one here. So I can go back to my input, or my geometry input at the start, and I might move my back cantilever, maybe not that far forward, but maybe to this one here. I can go back, I can rerun that analysis. And I can now see that this is very, it's a lot better utilized. And I mean, I guess you might ask, well, what's the point? You know, I can just do this in SpaceGass. Well, yeah, you can, but it's, you know, it's going to take you a little bit longer to do that. And then also, you're not going to be, it's going to be harder to actually understand what impacts that might have, say, on that strut element in terms of forces and stuff like that. So it allows you to, I guess, do it in quite an efficient manner. So that's the end of this series of videos. I hope that you've enjoyed it. I know it's been quite a bit longer than the typical videos that we'll put out, but I hope this can really, I guess, be a bit more, or give a bit more clarity around some of the more specific types of things that you can do with these types of tools, and especially with the SpaceGass analysis package as well. So look, thanks for listening. If you've got any questions, don't hesitate to get in contact with us. The best way is probably either through the forum, through the Rhino forum, or contacting us at support@geometrygym.com. We're always happy to take feedback and suggestions. So yeah, thanks a lot for listening.